Hi, hello everyone. Welcome to this video. So in this video, we're going to cover usage of our vertex buffer, right? We're going to try to pass it to the pipeline and then render our triangle. And by the end of the video, quad from this vertex buffer. So we can immediately start. Just to recap, so basically we created this buffer, but we never used it in last video, so we just want to use it. And for that, we're going to need a new pipeline. I don't want to change and modify this triangle pipeline, so we're just going to create a new set of shaders and then the new pipeline as well. So let's just start with the shader. And here I'm just going to create a new vertex shader. I'm going to call it position, color, vertex shader. And this time we can actually compile it by Visual Studio. We don't have to worry about compiling it from the outside, I guess. Actually, we haven't covered compilation. For now, it can just be text file which gets copied to our output. And if you remember, we had in our vertices this position color vertex, which has position of float 3 and then color of float 4, right? Vector 4 is color. So we're going to use a similar thing in our shader. So we're going to have float 3 position, and this is position. Oh, come on. And then we have color as well, which is float 4 this time. And then we can actually, this position, we're not just going to output position, so we're going to move this out. We're actually going to output struct, right, which is going to be float 4. Be mindful here, because when you pass from the vertex pipeline, so the vertex pipeline can take vertex in any form, but when you're passing it out, it must be float 4. And with this S3 position semantic. And then we're going to pass color as well. So color. So what are we doing, right? Our shader input, right, from our buffer is going to come into this form, and then we just pass this as a shader output. So we're going to pass through the pipeline, position and color all the way up to the fragment shader or pixel shader, as it's called in DirectX. So we have to say here vertex shader output, and we can create that output. And this position is not input anymore, actually our input, vertex position input, and we can just call it input. Very simple. I think this code will be very simple. So we just have to say output position, and be mindful here, it's float 4, right? And the last W component is 1, and then color we can just paste in, and then we say output here as well. So we just need to make use of this in fragment shader or pixel shader. I'm still not used to it. Then let's go to our pixel shader. So we're just going to call it color or position color actually, and then PS for pixel shader. So we can simply copy our output. We can say here output, and I think this can be in different name as well if you wanna. It's just important that these semantics are the same. So that's why we have them, I guess. But here I'm not going to bother with it. And this is all right. We just need output.color. We don't worry about the position at all here. And those are our shaders. If everything is all right with them, they should compile, since they're actually now in the project. And they do. So everything is all right, we can assume. Then what we want to do is just create a new pipeline, and I'm going to call this one position color pipeline. And of course it moved this outside, even if I thought that it's going to be in pipelines. This is so annoying. I'm not sure why is that. If somebody knows, please let me know. But let's go with position color pipeline, and I'm just going to be lazy here, copy this, copy here, and then rename it position color pipeline. So we need to rename here as well. All of this is fine, but in our render, right, we're now going to take in that vertex shader. So we need, sorry, not vertex shader, vertex buffer. And the second parameter, we also need this position color vertex, right? And then we can say here vertex buffer, position color vertex, and we're going to pass just a reference to it. and then we can say vertex buffer, and we can make it const. And that's it. I guess that this is fine. So let's go to our CPP, and I'm just going to copy triangle test pipeline, move it here, and then rename it once again because I'm very lazy. Position color pipeline. Let's just change everywhere. And of course, render is now taking in that const vertex buffer, position, color vertex, which is reference, and then vertex buffer. And it's complaining about something, probably because I haven't used const. I have actually. So it's complaining for no reason at all. Okay. My bad. I realized that I used position color pipeline instead position color vertex here. So we need to change that in H file as well. I actually haven't noticed it. So let's do that. Okay, that should be fine now. So let's just move this here as well. And then we rename the shader to position color vertex shader. And then this is position color pixel shader. And now we have to make use of this buffer, vertex buffer, so we can do that. Of course, it's not going to work because we need to describe our data, but more on that bit later. So here we can say context and then vertex, set vertex buffers, and it has 5 parameters. The first one is our buffer position. It's going to be 0 because it's just in the first position. So if you had another buffer, let's say that we did position and color separately, like 2 buffers, you would set second buffer to position 1 and the first buffer to position 0. So here it's just going to be 0. Number of buffers, it's just 1 buffer. Then we need to paste that buffer in. And I realized in our vertex buffer, we need to expose this buffer, right? Underlying buffer. So many buffer thingies, and so yeah, it can be just this like comp pointer of DirectX11 buffer, get buffer, that's fine. Then we can go here, get buffer, and we need address of that buffer. And I'm just going to break it into a couple of lines because it's easier to see. And then fourth and fifth parameter are stride and offset, so that's very easy. So we're just going to say here uint stride and its size of position color vertex. So I'm going to comment on stride a bit later as well, but just know that it needs to be size of this position and color. So it needs to take into account this and this, right, when it comes to size. So it will be here 3 for position, 3 plus 4, right, for 4 colors, and that's it. And then times size of float. We're going to use all floats almost always, except for indices. But more on that later. And then we need the offset, and we just need to paste pointers. This. And I think this is fine. So this is our buffer. Good. Good. So we need to learn something about this pipeline layout, because what we have now is our buffer, and buffer can be any data, so it doesn't matter, like it can be in various formats, but we need to describe to our vertex shader how does it read it. So here we need to describe that, and we do that with pipeline layouts. So I'm just going to explain a bit what pipeline layouts is, how can they be assembled, and then we're going to actually create pipeline layout. Just to explain this like input assembly thing and how do we create it. So essentially here, if I take this, we can see that we have this struct, right, which is vertex shader input, and it consists of position and color. And so we can represent and push that in 2 ways. One way we already did, and that's going to be our preferred way, where we actually take like the first part of this buffer for position, right, and then we take the second part of our buffer for color, and let's say this is vertex 1. Then we have position again, right? If we imagine our triangle being here, let's say we have vertex, actually let's call it v1, then v2 and v3, and we need to pass the data in. So we're passing color here again for v2, and then for this one we continue with vector 3. You get the idea. The second way of passing the data in is actually organizing by having two buffers. And then we can say v1 here, we can have position, right? And then we can have color in this one. For v2, we're going to have position again, then color again. And then for v3, we're going to have position and then color again here, right? So these are two ways to organize data. This one is called, I believe it's array of structures, because it's just a one array of structures inside of an array, and this one is called a structure of arrays, right? Because you have multiple arrays. So structure of arrays. And we already created our buffer with this way, and we're going to use that one, but just so that you know, like, you don't have to use one buffer. You can actually organize with multiple buffers. All right, then let's try to create a pipeline layout. So we're just going to need here, I'm just going to create a new class, pipeline layout util. Okay, so actually it's not pipeline, it's input layout util, right? We're going to call it input layout util. And it's complaining about something. Let me check that. All right, let's try again. So new class, input layout util. Okay, good. Now it has created it. So that means that in our position color pipeline, we're going to need to have that input layout, and we can create it here. It already gave a good suggestion. So we're going to create this object, input layout. Let's go to our input layout util. And then we're going to have public, static. Let's include this. No help here, so we're going to do it like this, using namespace as usual. And then here I'm just going to create position color input layout. And it already gave me suggestions, but let's remove it because this is of no use to you. So device, we're going to need it because we're going to use device to create it as usual. Then let's just start with it and see what we're going to need. So this is going to be our result, input layout. This is final result, right? And as usual, we have h result. H result is equal to device, right? And then create input layout. All right, let's see parameters. First one is input element description, and as you can see, this is pointer to input element descriptions, so it means it's an array, a number of elements, right? This is going to be very easy. This one is actually from our vertex shader blob, and you're going to see how it works. Size is sides of our vertex shader blob, right? Because when we create it, it needs to know about vertex shader, right? So we paste that blob that we had previously from which vertex shader was created. We're going to paste it in here, and finally the last parameter is a result. So let's start actually filling this in. So the first object is the 11 input element description, I believe. Yes, and then layout. So here it's giving some suggestions, but let's fill this in one by one. So first one is position. So what does this position refer to? Well, of course, it refers to this position here. And then the second one will be color. So here is 0. What does 0 refer to? It refers to our buffer, right? It's going to be at location 0. Actually, my bad. it's not the location of a buffer. It actually needs to correspond to, where are you? This number here. So we can say here position 0 as well, and we might pass in different semantics here. But if we had another color, so let's say float of 4, like normal color, and then we would use color 1. So here in our input layout, where are you? We would say here, for example, color 0, it's color, and we would say 0, but for the next one we would say 1, if that makes sense. And you're going to see as we go further and further with this series, it's all going to make sense. So let's remove this. This is fine, these two. Then our input layout, and then we have third parameter, which is format. So these formats are a bit, let me see. So it will be something like DXGI format R8, B8, G8. So no alpha, second. So it's not 8, it's actually 32 because it's in bits and then it's float. All right. So these formats are kind of hard to read, and my suggestion is like actually try to type for this parameter and then see the list here of all the formats. But essentially what we need is this format, which is for vector 3, and then we're going to use this format, which is for vector 4. So just that you're aware of this. It's probably easier to like Google what this is and then check documentation. So this is our format for position. The next parameter will be input slot. So now it's that slot for our vertex buffer, and it's at position 1. If we had multiple buffers, the second one would be at position 1, the third one at position 2. Here we're just placing 0. Then the next parameter is aligned by the offset. So we don't have any offset for the first one, so we're going to have for the second one when we describe it. And then the third parameter is type of data, which is per vertex data. So we're passing this data per vertex. In future we're going to cover instance data. And then the last parameter is instance data step rate. Not relevant, it's just going to be 0 for us. If we cover instance data in next video, then we're going to take a look at it. So I'm just going to copy paste and then like change the important ones. So color, why color, right? If we check our vertex buffer, here we're using color. So that's why it's color, and it's float 4. So here we're just going to add a 32. Then this parameter was offset. This can remain 0 because we're using iterative data, right? Everything is in one buffer. If we use 2 buffers, like I mentioned, this would be 1 for the second one, and then offset would be 0. But since we're using iterative data, and you can check that here, right? This is our first. So we have to take account this 3 for the offset, and then size times size of float, and then it's the second, the color, we're describing it here. So it's going to be 3 times size of float. We're offsetting for a position, and then the next parameters, this can remain the same. Good. So we can just paste that in. We have device create input. So array size, we can just say actually 2, because we have 2 of these element descriptions here. Shade the bytecode. Okay, this is bad suggestion, of course, because we haven't pasted it. So we're just going to say here, then blob. So we need vertex shade blob, and then we have to use that blob. We get pointer to a blob, and then we get size of the blob, and then we just say to input layout So basically last parameter is just this input layout. It's going to say this variable. Interestingly enough, doesn't recognize H result for some reason. Aha, because here I'm missing this. This is fine then. Then if failed, we can return some error, failed to create the input layout, and doesn't recognize it because we need to include the IO string, right? And the last parameter we can just say here const entity string debug name, and by default I suggest position color input layout is fine name, so we can actually set it. And then sorry, if you remember from the last time, if we have debug name, we can set this private. We can set this private data, which is just debug object name, and then we pass in the size of it and the pointer to the C string, and then we just return the input layout. Okay, that was kind of long, so I'm just going to copy all of this, then remove it here because we're actually going to create CPP file here. So I could have done without it. So we just don't need method name. So we just need our inner code here. Right, from the input layout to the input layout until we return it. And I'm just going to break this so that it's easy to see parameters. Okay, then let's try to create it. So that means in our position color pipeline, we already defined input layout here. It says create shaders. Might be good to create shaders in the input layout, but I don't care. I'm just going to create it here. So we need this vertex shader blob for input layout, and we can do it here as well after everything. So input layout. And of course we need to include this input layout util, and then it's just input layout util, and then create position color input layout, and then we don't even need third parameter because by default it has a pretty good name. And I think we're almost there. We just need to make use of it right over here. So it's very simple to set it up. We can just say context, set input layout, and it's input layout get. Like by the far one of the simpler methods here. And let's try to actually create all of this and then run it. So we're just going to need a pipeline. Position color pipeline. And we can create it here, position color pipeline. And then we just use it here, position color pipeline, render. And I'm just going to comment this one out, triangle pipeline, to see if this works. If it works, that would be great. Let's see. And moment of truth, it does work. Perfect. All right then. So now we have this, and we can just try to draw a quad, because now it's easy, considering that we're actually passing the buffer in. So we just need new vertices here. Although, if I remember correctly, so here we had this draw tree, which is obviously wrong. So in our vertex buffer, we're just going to have a new parameter here as well, which we're going to say. We could get it from the data, but your data can be just floats, so it's not a good idea. But we're going to say here size t, and then vertex count, I guess. Or it can be unsigned long, or unsigned uint. I guess that's fine as well. Oh, sorry, unsigned int. I'm used to C#. And here we can say vertex count, and then here we can say get vertex count. So in our position color pipeline, we just have to get that vertex count. So in the future we might want to have like some offsets. For now, no. So this is good. And now we just have to paste 3 here, correct? And we don't, sorry, I don't see anything, so something went wrong. Okay. Well, what went wrong obviously is I never assigned it here. So we're just going to say vertex count in our vertex buffer, and if I try to run it now, it should work properly, and it does work properly. So good. Let's just try to make this a quad. So you can say triangle 1 here, and we're just going to change this one to be like right-sided triangle. So top vertex, we have bottom right and bottom left vertex. So do I want to change it to, let me see my example, because okay, I think here we can say top left vertex. So it's minus 0.5 minus, no, sorry, 0.5, this is fine. And then we can say triangle 2. And here I already had some data, but let's type it out regardless. Actually, let me just copy paste this because I'm very lazy. So we're going to have top right, we're going to have bottom right, and then top left. So we kind of need to change the first one and the second one. And here we need comma. So this triangle becomes right triangle. So we just need to change this. And the last one becomes top. And if I try to run it now, I guess it should work. No, maybe I did something wrong. Of course, I'm stupid because here it's still 3. So I'm just going to do this actually size, right? So I don't have to think about it. And now it works. So the colors are all wrong, obviously, because I haven't matched really the colors here, but that's totally fine because next time we're going to use indexed buffers or indices, and then this is going to be all right. And what indices will allow us is to actually not have to duplicate, like, for example, this bottom right vertex, which is now duplicated, and then the top left vertex as well. It's not going to have to be duplicated with indices, but more on that next time. So this time I just want to recap this because it's a bit complicated, but not that much actually. Basically, all we had to do was prepare our vertex buffer, which we did last time actually, and then in order to use that vertex buffer, we just had to create input layout. And what does input layout do? Input layout simply describes, let's go actually, where did we create it? Here. So what does input layout do? It just describes our vertex data, right? Which we can see right over here. We just need to describe this and our vertex buffer, how the data comes in, and that's all that it does. We just create it. We needed to paste vertex shaded blob, very simple. So nothing too much here, and then we just had to make use of it right over here, and also the use of vertex buffer. That's it regarding this video. So next time we're going to cover indices, after that textures, and that's when it gets really exciting because we're going to try to do a bit of engine development. But anyway, if you like this video, maybe like, leave a comment, subscribe, and until next time.